If I had to choose the best word to describe what SpaceX achieved with Super Heavy on Flight 8, it'd have to be incredible. Despite all the controversy, the successful landing of B-15 is undeniable, but what comes next? How will SpaceX move forward, upgrade, and improve B-15? And the biggest question, can it fly again? Let's dive in and find out on today's episode of Great SpaceX. I wonder if anyone else keeps rewinding the Flight 8 livestream just to relive B-15's incredible landing over and over again. No? Just me? Okay. SpaceX has only added to the excitement, recently sharing even more stunning footage, images, and videos on social media, showcasing every thrilling moment of B-15's activation, liftoff, and near flawless landing. It was truly fascinating. The entire sequence was remarkably smooth, from the booster's approach to its final moments being caught by Chopsticks. It all happened as if SpaceX had done it 100 times before. At this point, it's safe to say that they have mastered this technique. But what makes this feat even more impressive is that B-15 had a far more dramatic journey than the two previous boosters that successfully landed. B-12 had no major engine failures, only experiencing a small fire at the end of the flight. B-14 lost one engine, but it reignited in time for landing. B-15, however, faced even bigger challenges. It lost two engines, with only one successfully reigniting. That added some tense moments for viewers, but despite the setbacks, B-15 nailed the landing. This achievement marked the third successful landing of a Starship booster and the second in a row within just 7 weeks, a testament to how fast SpaceX is refining its landing techniques. But what's next for B-15? On launch day, about an hour after landing, Chopsticks carefully lowered B-15 onto the OLM. At the same time, a booster transport stand was moved into position, preparing to retrieve the returning hero. By that evening, B-15 had arrived at the launch site. Then, on March 7th, the booster was officially lifted off the OLM and placed onto the transport stand. Chopsticks retracted, signaling the start of its next journey. According to the road closure schedule, B-15 began moving around 11:30 p.m. Central, heading to the production site where it was eventually placed inside Megabay. Now, B-15 will undergo detailed inspections to determine its condition. The engines will receive the most attention as they endured an extra prototypes. Based on what we saw during Flight 8, B-15's engine problems seem similar to what happened on B-14 during Flight 7. The likely culprit, a low-power igniter system which may have prevented the engines from properly reigniting after shutting down for stage separation. If that's the case, further ignition system upgrades will be necessary. Another key area of focus will be the pressure system, which directly contributed to the scrub on the 3rd of March. According to Musk, the ground spin start pressure was too low, preventing the booster from generating enough thrust for liftoff. While SpaceX managed to fix the issue quickly, it may have only been a temporary solution. A more robust upgrade at the production site will likely be needed to prevent this problem from recurring. As SpaceX continues refining Starship's design, each landing brings in valuable lessons. The next steps for B-15 will be crucial in determining whether it gets another flight or simply serves as a stepping stone for future boosters. Either way, this marks another giant leap toward full reusability. With B-15 now safely back at the production site, the big question is, how will SpaceX upgrade and improve it further? One major area of focus will be the hot staging system, particularly the clamp system. This mechanism was responsible for halting a stack attempt during pre-launch preparations, so SpaceX will need to ensure that it functions flawlessly in future flights. More importantly, a reliable hot staging system is critical for seamlessly connecting and separating the two rocket stages, a key factor in achieving efficient stage transitions during flight. For the engine system, SpaceX will likely continue refining the ignition system, which was upgraded before Flight 8. However, additional enhancements to engine components or the addition of protective systems could help ensure greater durability and reliability for future flights. But the real game changer could be Raptor 3. This next-generation engine has been teased for quite some time, yet we haven't seen it implemented on a flight-ready booster. If B-15 is reused, it could be the perfect candidate for testing Raptor 3, especially since the earliest Super Heavy boosters are expected to fly a maximum of 2 times. Could this finally be the moment Raptor 3 makes its debut? Let us know what you think in the comment section down below. The clamp system used in hot staging caused an issue during pre-flight stacking, but this was the first time a problem has been reported since its introduction. This suggests the fix shouldn't be too complicated. It may simply need reinforcements to improve stability and flexibility during the stage connection and separation phases. Another critical issue to address is the pressure system, which was the direct cause of the scrubbed launch attempt on the 3rd. Musk explained that ground spin start pressure was lower than expected, leading to insufficient thrust for liftoff. Although SpaceX quickly fixed the issue, the fact that it occurred at all suggests a need for more permanent enhancements. One potential solution could be improving the turbo pump system to increase pumping power, ensuring the booster achieves the necessary thrust consistently. With detailed inspections and upgrades underway, the next steps for B-15 are crucial in determining its fate. If the booster checks out with no major issues, it could compete for a spot as one of the first reusable Super Heavy boosters. Regardless of whether it flies again, every upgrade and improvement made now will directly benefit future Starship boosters, ensuring SpaceX continues its rapid progress toward full reusability. In fact, the B-16 prototype, which is already undergoing cryogenic testing, could be the first to incorporate some of these refinements for its upcoming Flight 9. This is the big question everyone wants answered. As of now, based on what we've seen, B-12 is unlikely to fly again, meaning the most promising candidate for reuse are B-14 and 15. Both 14 and 15 could potentially fly again, especially if SpaceX decides to use them as testbeds for upgrades like Raptor 3. However, the challenge lies in the fact that new boosters are already lined up, each waiting for its turn. B-16 is currently undergoing cryogenic testing and is next in line for Flight 9. Hey, that rhymed. While B-17 has already been fully stacked and stands ready for its mission. Meanwhile, B-18 has been hinted at and may even mark the introduction of Booster Version 2, a significant leap forward in design and performance. With SpaceX looking ahead to these newer prototypes, the opportunity for reusing earlier boosters may be limited. Now, if SpaceX were to only use one booster, well, B-14 has a slight advantage, and here's why. B-14 has been waiting since January, meaning it has had more time for refurbishment and could be ready sooner than B-15. 14 only lost one engine, while 15 suffered 2 engine failures and will require more extensive inspections and upgrades. That being said, 15's landing was a major success, proving that it is still a strong candidate, especially if inspections and upgrades are completed quickly. What do you think? Place your bets. Will B-15 get another flight, or will SpaceX prioritize newer boosters? Which Super Heavy booster do you think will be the first to be reused? Drop your predictions in the comment section down below and let us know why. Don't forget to like the video and subscribe to the channel so you don't miss the latest updates on SpaceX's development journey. In other exciting news, as preparations for the Crew 10 mission to the ISS ramp up, SpaceX has officially moved its Dragon spacecraft to the factory at the launch complex in Florida. The update came on the 5th of March when SpaceX shared stunning images on X showing Dragon being transported on a trailer before arriving inside the factory. The post read, "Dragon arrives at the hangar at Pad 39A ahead of next week's launch of NASA's Crew 10 mission to the space station." Following its arrival, Dragon was swiftly prepared for the next crucial steps, being stacked onto Falcon 9 for final testing before its highly anticipated flight. Right now, liftoff remains scheduled for March 12th at 7:48 p.m. Eastern from Launch Complex 39A, the same historic pad that has supported countless iconic missions. Aboard Dragon will be a crew of 4 astronauts, each representing different space agencies. NASA astronauts Anne McClain and Nicole Ayers, JAXA astronaut Takuya Onishi, and cosmonaut Kirill Peskov of Roscosmos have already undergone rigorous pre-flight testing, ensuring they're ready for their exciting voyage to the ISS. Interestingly, the Crew 10 mission was originally supposed to use a brand new Dragon capsule. However, due to delays in its development, NASA and SpaceX pivoted to using Dragon Endurance, a capsule originally planned for a different mission. This last-minute switch helped keep Crew 10 on schedule, preventing further delays. While Crew 10 is primarily a routine crew rotation and resupply mission, it holds extra significance due to its impact on Crew 9, particularly regarding the return of 2 Starliner astronauts. Crew 9 is currently responsible for bringing back Butch Wilmore and Suni Williams, two astronauts from Boeing's Starliner mission who have been on the ISS for over 9 months, far longer than their original 8-day plan. Starliner encountered technical issues that prevented it from returning with its crew, forcing NASA to rely on SpaceX's Crew Dragon to bring them home. If Crew 10 launches as planned, it'll reach the ISS in just 14 hours, arriving on the morning of March 13th. The handover period between the two crews will last about a week, meaning Crew 9 will likely return around the 20th of March. All signs indicate that Crew 10 preparations are going smoothly and the stranded Starliner astronauts will finally be heading home soon. However, since Falcon 9 has experienced minor technical issues in the past 6 months, SpaceX is being extra cautious with launch preparations. As we count down to liftoff, let's send our best wishes to both Crew 10 and Crew 9 for a safe and successful journey. Drop your messages of support in the comment section down below.
To see the Super Heavy booster gliding down into the Chopstick arms once again.
Oh my god. What you just witnessed with B-15 is nothing short of spectacular, a testament to the 8th flight of SpaceX's Starship. But of course, we can't ignore the issues with S-34. There's a lot to break down. So how did the latest flight unfold? What went wrong and why? Get ready, because this is shaping up to be one of the most important episodes of the month on Great SpaceX. Yesterday at Starbase, excitement was in the air as all eyes were on Starship S-34 and Super Heavy B-15. In less than 10 minutes, the flight delivered stunning results. B-15 successfully landed on Mechazilla's arms, while S-34's engines encountered issues, leading to a loss of control. For B-15, the journey was mostly smooth, though not without problems. 2 engines failed to fire during the boostback burn, and during the landing burn, only one of the 2 reignited. This issue seems similar to the previous flight, where SpaceX identified the cause as a low-power condition in the igniter system. It appears the fix wasn't enough, leading to the same problem occurring again. Meanwhile, S-34's situation looked eerily familiar as well. Based on initial observations, the likely cause was excessive pressure leading to leaks and fire, which damaged the engines. When cameras zoomed into S-34's engine bay, small fires were visible in 2 of the vacuum engines. Another video from Mission Control showed an RVAC engine explosion, suggesting that a thrust imbalance may have contributed to S-34's rapid unscheduled disassembly. A potential cause could be the new RVAC feed lines. SpaceX had previously stated that they had improved the venting and fire suppression systems, yet these enhancements were not enough to prevent the failure. Following the incident, SpaceX took to X to provide an update. During Starship's ascent burn, the vehicle experienced a rapid unscheduled disassembly and contact was lost. Our team immediately began coordination with safety officials to implement pre-planned contingency responses. We will review the data from today's flight test to better understand the root cause. These are the key takeaways from the flight, though we'll need further updates from SpaceX to get a clearer picture. Now, let's go over the entire flight to gain a better perspective, because despite the setbacks, this launch marked significant milestones. As usual, fuel loading went smoothly and followed the planned timeline. The Starbase launch site was engulfed in intense venting, and frost formed on both stages of the rocket. At exactly 5:30 p.m. Central, Super Heavy's 33 Raptor engines roared to life, generating over 7,000 tons of thrust at liftoff. The rocket cleared max Q, and at T plus 2 minutes and 33 seconds, second engine cutoff occurred, shutting down the outer and middle ring of B-15's engines while leaving 3 center engines active. Hot staging followed, successfully igniting S-34's 6 engines for stage separation. However, as previously mentioned, engine failures soon became evident. Instead of the one like in Flight 7, this time 2 engines failed to restart. Fortunately, the booster still retained enough thrust to continue its controlled descent. At T plus 3 minutes and 39 seconds, B-15 shut down its middle engines, and at T plus 4 minutes and 6 seconds, the inner engines followed, putting the booster into transonic descent. The hot staging ring was jettisoned at T plus 5 minutes and 9 seconds, marking another smooth step in the process. Then came one of the most exciting moments, the booster's return. At T plus 6 minutes and 34 seconds, B-15 was only 1 kilometer away from the tower, traveling at 1,150 kilometers per hour when the landing burn began. Unfortunately, due to the earlier boost back burn issues, only one of the two middle ring engines reignited. However, the good news was that one did successfully re-engage, similar to what happened during Flight 7. With 12 engines firing, B-15 rapidly decelerated. At T plus 6 minutes and 41 seconds, the middle engines shut down, leaving 3 inner gimbal engines to steer and finalize the landing. By T plus 6 minutes and 48 seconds, the booster and tower were visible in the same frame, a moment of pure adrenaline. Below, the chopsticks opened to catch the rocket, and at T plus 6 minutes and 55 seconds, B-15 made contact. Within seconds, the chopsticks closed in, securing the booster. At T plus 7 minutes and 2 seconds, B-15's landing pins locked onto the chopstick rails, signaling a successful catch. This marks the third time SpaceX has successfully landed a booster using Mechazilla and the second consecutive success. It's becoming routine, a testament to SpaceX's rapid progress. B-15 will likely return to the production site soon for refurbishment, making room for the next launch preparation. But while the booster's landing was a huge success, S-34's fate wasn't as fortunate. After several minutes in flight, at T plus 8 minutes and 5 seconds, the first vacuum engine shut down, following shortly by the 3 inner engines. Losing its thrust balance, S-34 began to spin out of control, evident from the onboard camera views. By T plus 9 minutes, the signal was lost, briefly returning for a few seconds before cutting out completely at T plus 9 minutes and 13 seconds. With such an issue, hopes for continued flight were slim. It appears that the flight termination system was triggered again, leading to an explosion. Reports indicate that the fireball was visible from Cape Canaveral, Florida, and burning debris was observed over the Dominican Republic and the Bahamas. So another incredible Starship flight comes to an end, filled with both successes and challenges. As SpaceX emphasized, as always, success comes from what we learn, and today's flight will offer additional lessons to improve Starship's reliability. Failures aren't setbacks, they're stepping stones. Each flight brings vital data, paving the way for a fully operational Starship. So if you still believe in SpaceX's vision, show your support. Type "never give up" in the comment section down below, like the video, and subscribe to stay updated on SpaceX's groundbreaking journey. Now it's time to look ahead to what comes next. With S-34's failure, an investigation is almost certainly required. However, since the issue seems similar to Flight 7, the review process may be shorter than last time. SpaceX engineers now have more experience with this type of failure, which could streamline troubleshooting and accelerate the path to the next launch. One factor that may cause delays is the aftermath of the flight. A major concern is where the debris has fallen and who may be affected. The extent of the impact on populated areas and airspace regulations will be key in determining how soon Flight 9 can proceed. If authorities require an extended review of debris handling and safety protocols, it could push back the timeline. With the current outcome, it is likely that Flight 9 will still need to land in the ocean rather than attempting a catch with Mechazilla. This means that the first ship catching test may not happen until Flight 10 or later. On a positive note, SpaceX has made major strides in booster recovery. The Super Heavy catch mechanism is now proving to be consistent and reliable, allowing the team to shift focus toward fixing the ship's issues for the next test. In terms of hardware progress, B-16 is currently undergoing cryogenic testing, while Starship S-35 has completed production and is ready for testing. Once B-16 completes its tests, it'll likely be rolled out for more advanced evaluations, while S-35 will remain at Massey for further preparations. If the investigation wraps up quickly and testing stays on schedule, we might see the next flight as early as April. Do you think that's possible? Let me know with a yes or no in the comments down below. And for our final piece of news today, let's turn our attention to China and its latest remote sensing satellite launch, a mission that underscores the country's growing ambitions in space. On the 27th of February at 2:08 a.m. Eastern, China successfully launched a Long March 2C rocket from Jiuquan Satellite Launch Center, carrying a pair of remote sensing satellites known as SuperView Neo-1. These satellites have now joined China's commercial high-resolution remote sensing constellation, operating in low Earth orbit at an altitude of approximately 500 kilometers. Shortly after liftoff, the mission was declared a success. However, details about the specific purpose of the satellites remain undisclosed. The China Aerospace Science and Technology Corporation, or CASC, the primary contractor for China's space program, described the payload as part of the China's Suwei new generation commercial remote sensing satellite system. This system is designed to support remote sensing applications such as mapping, surveillance, and imaging, advancing China's high-resolution agile imaging satellite technology. According to CASC's official statement, the newly launched satellites possess ultra-high resolution, high agility, high positioning accuracy, and high-capacity, high-performance data transmission capabilities. Their overall performance metrics are reportedly on par with international advanced standards, strengthening China's position in the global commercial remote sensing satellite market. The previous pair of satellites launched by China in November of 2024 featured high-resolution synthetic aperture radar, or SAR technology, a capability that allows for detailed imaging even in poor weather conditions or darkness. This suggests a pattern of strategic expansion in China's Earth observation capabilities. However, despite the mission's declared success, there are already signs of potential issues. Observers have noted that insulation tiles from the rocket's upper stage and payload section appeared to have fallen off during ascent. This is not the first time such an issue has occurred in a Chinese rocket launch, raising questions about the reliability and durability of China's launch vehicles. As of now, CASC has not provided any updates regarding this anomaly. With this latest launch, China has now completed 9 successful orbital launches in 2025. After falling short of its goal of 100 launches in 2024, the country is now pushing aggressively to reach that milestone this year. This will require a significant acceleration in both government-backed and private sector spaceflight efforts. China's recent surge in space activity presents a major challenge to other spacefaring nations, particularly the United States. The country has dramatically increased its launch frequency in recent years, expanding into a wide range of space missions. Beyond remote sensing satellites, China has ambitious plans for space station operations, lunar exploration, asteroid missions, and even Mars projects. These developments signal a strong commitment to becoming a dominant force in space exploration. That being said, China still lags behind in certain key areas, particularly in reusability, cost efficiency, and launch cadence, all areas where SpaceX continues to excel. Last year, SpaceX alone launched 138 missions. That's over double China's entire national effort of 68. The private spaceflight industry in the United States, led by SpaceX, remains far ahead in technological advancements, reusability, and overall launch efficiency. So while China is making bold strides, the U.S. space industry still leads the race for now. The real question is, how will American space organizations respond to China's rapid advancements? Let's wait and see how NASA, SpaceX, and other key players push forward after this latest update from China. A year ago, Elon Musk shocked the world with the introduction of V2 and V3. Now, V2 has been deployed. But what about V3? Many believe it's still years away, but what if it's closer than we think? Recent challenges with V2 suggest that V3 could make an earlier debut than expected. So when might it be implemented? And why could it soon replace V2? Perhaps no other flight has made viewers feel as nervous, anxious, and excited as Flight 8. Although the delays weren't excessively long, they were frustratingly frequent, even halting the countdown with less than a minute to go. But eventually, everything was resolved, and the flight took off. However, as you saw, Flight 8 once again exposed critical issues. While the mission achieved the impressive milestone of the third overall and second consecutive successful capture of the booster using Mechazilla arms, there were still problems with Super Heavy's engines during the boostback burn. But the real focus was on the ship. The second version of Starship V2, S-34, exhibited the same failure as its predecessor S-33. Once again, it seemed that pressure issues and fuel leaks led to engine failures, ultimately causing the ship to lose control. This raises an important question. Do we need a breakthrough upgrade to solve these persistent issues in V2, perhaps pushing forward directly to V3? At first glance, it might seem unbelievable, but considering recent developments, it's entirely possible. The repeated delays and failures in Flight 8 revealed multiple problems affecting various parts of the vehicle. First, Super Heavy encountered a pressure issue. According to Elon Musk, the fuel pressure during transfer from the tank to the engines dropped below the required threshold, which affected performance and nearly jeopardized liftoff. Next, the ship had issues as well, although the exact nature wasn't fully disclosed. However, we did see workers inspecting the liquid oxygen tank area, suggesting a possible problem. Additionally, during the stacking attempt on the 5th of March, a heat shield tile detached from the ship, sparking concerns about the system's integrity. Further complications arose with the hot station clamp system, which was found to be faulty. Even Chopsticks, the crucial catching mechanism, had a skate system issue. These recurring problems forced SpaceX to take extra time for troubleshooting before they could re-attempt stacking and launch. Although they resolved these issues relatively quickly, they still caused delays, raising concerns about whether V2's design upgrades are truly effective. V2's issues were evident even before Flight 8, particularly in Flight 7. On that flight, Super Heavy performed exceptionally well overall, but one engine failed to ignite during the boost-back burn. SpaceX later explained that the failure was due to the safe abort system activating in response to a low-power condition in the igniter system. Fortunately, the engine managed to function properly later, assisting in the Super Heavy landing. S-33, however, was a different story. The ship suffered catastrophic failure and exploded just minutes after liftoff. Musk later confirmed that a fuel leak had caused an excessive pressure buildup in the cavity above the engine firewall, leading to the explosion. SpaceX's official update added that harmonic resonance was too strong during flight, increasing stress on the propulsion system. This caused a fuel leak, pressure spike, and fire, ultimately leading to the destruction of the vehicle. Furthermore, a fire was observed in the aft flap system, suggesting that the current flap design is suboptimal. Taken together, these issues suggest that the V2 design has fundamental weaknesses. So why not introduce a radical upgrade, such as transitioning directly to V3? But what exactly would V3 change? V3 would undoubtedly bring major design improvements. For starters, Super Heavy would undergo modifications to its hot staging system, the same system that caused problems before Flight 8. The new hot staging design would be simpler, more efficient, and optimized to reduce risks while improving production, operation, and refurbishment processes. It would also be lighter, boosting overall flight performance, a critical step toward full reusability. Most importantly, this redesign would minimize the impact caused by stage separation, enhancing reliability. Next, the engine system would see significant upgrades. V3 would feature Raptor 3 engines, which are not only more powerful, but also simpler and far more reliable than Raptor 2. These engines directly address the failures seen in Flight 7. Along with the engine improvements, the fuel tank system would be expanded to accommodate the increased fuel demands of Raptor 3, providing greater efficiency. Furthermore, the launch pad infrastructure, including Chopsticks, would receive optimizations to eliminate persistent issues and enhance long-term operational reliability. With all these improvements, V3 would directly resolve the shortcomings of V2, so why not make the switch now to accelerate Starship's journey towards stability and reusability? Beyond technical enhancements, the urgency of transitioning to V3 also stems from upcoming mission demands. According to Lisa Watson-Morgan, NASA's manager of the Human Landing System program, V3 needs to be operational by the end of this year to support the development of the orbital refueling system. This refueling system is essential for Starship's deep space missions, providing the fuel necessary to reach destinations like the Moon and Mars. It could function in one of two ways. Either Starship tankers would transfer fuel directly to the main ship in orbit, or a fuel depot would be established, allowing the ship to refuel as needed. In both scenarios, V3 would be instrumental in ensuring efficient and reliable fuel transfer, making it a critical component of SpaceX's long-term mission plans. This version of Starship is expected to be significantly larger than V1 and V2, with a total height of 150 meters. Super Heavy would stand at 80.2 meters tall, while the ship itself would reach 69.8 meters. As a result, Starship V3 would carry far more fuel, 4,050 tons in Super Heavy and 2,300 tons in the ship. Combined with engine optimizations, V3 would drastically improve refueling efficiency. Additionally, Lisa Watson-Morgan revealed that V3 will feature specialized hardware designed specifically for refueling operations, including advanced coupling mechanisms and quick disconnect systems. These components, which were absent in V2, are essential for ensuring the safe and efficient transfer of cryogenic fuel, further enhancing Starship's capability for deep space missions. Clearly, V3 is better suited for the refueling mission. Starship's development is advancing at an incredible pace, with SpaceX setting an ambitious timeline for its missions. Uncrewed Starship flights to Mars are planned within the next 2 years, followed by crewed missions just 2 years later. Additionally, Starship HLS is scheduled to land humans on the Moon in 2027. With 2025 already underway, the systems required for these groundbreaking missions must be built and tested without delay. For these ambitious plans to succeed, V3 needs to enter the launch phase as soon as possible, replacing V2. With V2's ongoing technical problems and the increasing urgency of future missions, the shift to V3 is much closer than most people realize. Do you support SpaceX's transition to V3 sooner rather than later? Reply on 3 in the comment section down below to let me know. Also, don't forget to like the video and subscribe to the channel to stay updated on SpaceX's groundbreaking journey toward the future of space exploration. Before SpaceX can fully implement Starship V3, they must first refine and perfect the operations and upgrades associated with the current V2 model. The foundation of this progress is mastering the landing and recovery of both stages of Starship, particularly Super Heavy using the Mechazilla arms. With 2 consecutive successful booster catches, SpaceX has demonstrated growing confidence and expertise in this maneuver. However, the next major milestone will be extending this capability to the ship itself, achieving full stage reusability. This will not only push the boundaries of cost-effective space travel, but also lay the groundwork for essential future missions, including in-orbit refueling operations. In addition to perfecting the recovery system, SpaceX must continue expanding its orbital testing. Successfully igniting and operating Starship's engines in space will be crucial for deep space missions and establishing a reliable refueling infrastructure. While SpaceX has made significant progress, certain mission-critical steps remain unproven, most notably payload deployment. Issues during Flight 7 and 8 highlight the need for refinement in this area, as it is a fundamental requirement for carrying cargo and crew to destinations like the Moon and Mars. Addressing these concerns early will ensure that V3 inherits a solid operational framework. Upgrades and enhancements across multiple spacecraft systems must also be verified, including improvements to the flaps, engines, heat shield, and fuel tanks. While some V2 advancements are promising on paper, they have yet to be fully tested in flight. Since neither Flight 7 nor Flight 8 has reached re-entry with a fully functional heat shield system, this aspect remains an area requiring extensive testing. Ensuring the heat shield's durability will be critical for Starship's long-term reusability, particularly for missions involving frequent atmospheric re-entry. Beyond upgrades, SpaceX must also address persistent technical issues that have appeared in recent flights. Recurrent problems, such as leaks and pressure irregularities, indicate systemic weaknesses that must be meticulously corrected before advancing to the next iteration of the vehicle. These issues are complex and require careful engineering solutions, but resolving them will make future flights safer and more reliable. Tackling these recurring challenges will not only enhance Starship V2's reliability, but also smooth the transition to V3, preventing these issues from carrying over into the next generation of the spacecraft. Moreover, other key systems, such as hot staging, fuel tanks, pump systems, and even the Chopsticks, must be refined and optimized before SpaceX moves forward. Each of these components plays a critical role in Starship's overall functionality, and improvements in these areas will serve as an essential stepping stone for V3's success. Ultimately, the path to Starship V3 is already underway. By addressing Starship V2's challenges, SpaceX is laying the groundwork for the most advanced and powerful version of Starship yet. Once these refinements are complete, V3's superior size, power, and design will cement SpaceX's dominance, outpacing competitors who are still struggling to catch up. In many ways, SpaceX is not just developing the next generation of Starship, they are shaping the future of the rocket industry itself. The emergence of V3 will set a new benchmark for spaceflight, and its arrival could happen sooner than expected. With every test and every improvement, SpaceX brings Starship V3 closer to reality, making the dream of interplanetary travel more tangible than ever. So stay prepared, Starship V3 is coming, and when it does, it'll redefine the possibilities of space exploration. Success comes from what we learn, and today's flight will offer additional lessons to improve Starship's reliability. That's the message SpaceX has been emphasizing ever since Flight 8. But now, it's time to turn those words into action, especially with future launches happening at an increasingly rapid pace. Flight 8, featuring the V2 version of Starship, revealed a number of critical issues. So how will SpaceX tackle these challenges and push the vehicle closer to full reusability? Flight 8 carried immense expectations for the aerospace industry, serving as a crucial stepping stone toward full reusability. Some of those expectations were met when Super Heavy once again landed successfully. However, challenges remained. On this attempt, issues still arose. Problems with the ship, similar to Flight 7, but even more severe, and newly revealed damage at the launch site. There's no changing the past, so SpaceX now turns its focus to the future. While working with the FAA and addressing the aftermath of the flight, another critical priority is upgrading systems to resolve the issues that led to failure, paving the way for success in the next launch. Before diving into solutions, let's first review the key problems from Flight 8. For Super Heavy, engine failures during the boostback burn were once again an issue, this time affecting 2 engines. Then, during the landing burn, only 1 engine reignited, indicating that the other had completely failed. Fortunately, this did not compromise the landing attempt. For the ship, small fires broke out in the vacuum engines and leaks were detected in the sea-level engines. As a result, engines began shutting down one by one, leaving only 2 operational vacuum engines. This imbalance in thrust caused the rocket to lose control, ultimately leading to failure. As for the launch system, recent images reveal scattered ground support equipment and smaller components around the launch site, likely dislodged or blown away by the intense vibrations and dust kicked up during launch. Nearby cameras also sustained minor damage. Problems even emerged before launch. Super Heavy experienced an issue with its fuel pump system, failing to generate enough pressure to ignite its engines during the March 3rd launch attempt, forcing a scrub. Additionally, the hot staging clamp system encountered difficulties, possibly compounded by a problem in the ship's liquid oxygen tank system. The Chopsticks skate system also had issues while stacking. So, how will SpaceX address these problems? For the Super Heavy engine failures, the root cause in Flight 7 was identified as a low-power condition in the igniter system. It's likely that this same issue affected Flight 8, meaning that SpaceX's previous upgrade efforts must be maintained and further improved. Specifically, the igniters require additional refinement and protective measures must be enhanced to prevent engine damage or leaks. However, there is an even more promising solution: Raptor 3. Unveiled last year, Raptor 3 is expected to be significantly more powerful and efficient than its predecessors Raptor 1 and 2. More importantly, its simplified design eliminates many small sensitive components that have historically been failure points, reducing the need for extensive protective measures. This could be a game changer in preventing ignition failures and mid-flight shutdowns. Although the current Super Heavy variant remains in V1, introducing Raptor 3 early would allow SpaceX to evaluate its performance before implementing it on V2. This proactive approach could fast-track improvements across future launches. As for the pressure issue, SpaceX will likely reinforce its fuel pump system to ensure it can reliably generate the required ignition pressure. While this may have already been addressed after the March 3rd scrub, further refinements are necessary to prevent similar failures in upcoming flights. Regarding the hot staging system, the recent issue emerged during pre-launch preparations, but even minor setbacks warrant upgrades. There's speculation that the new hot staging design, which has been revealed in concept, could be applied to V2 and V3 Starship variants. Like Raptor 3, early implementation would provide valuable data before rolling it out on future Starships. For the ship, or second stage, SpaceX has attributed its failures to an excessive harmonic response in flight, which triggered leaks and fires. Flight 8 exhibited similar symptoms, reinforcing the need for upgrades. SpaceX will likely enhance its venting system and nitrogen purge system to better manage pressure and thermal conditions. Again, Raptor 3 is a potential solution here, offering improved reliability and fewer components vulnerable to harmonic vibrations. If Super Heavy is already considering an early transition, then perhaps it's also time for Starship to integrate Raptor 3, especially now that it has moved to V2. The liquid oxygen tank system issues are likely tied to the expansion of the fuel tank in the V2 design. Engineers may have overlooked certain reliability aspects during the upgrade, necessitating reinforcements. While SpaceX appears to have addressed the immediate problem post-flight, a more comprehensive overhaul is required. Overall, a full transition to Starship V2 or even an accelerated shift to V3 would be the most effective way to ensure compatibility and resolve lingering technical inconsistencies. For the launch system, constant monitoring is essential, particularly for critical components like the water deluge system, orbital launch mount, communications system, ship quick disconnect, and Chopsticks. The Chopsticks play a dual role, stacking Starship and catching Super Heavy. Given their importance, SpaceX must reinforce their mechanical integrity and implement better protective measures. In the long term, Pad B improvements may be on the horizon. If SpaceX opts against making drastic modifications to Pad A, they could instead implement their latest advancements in Pad B and later apply them to Pad A to enhance overall efficiency. Surrounding infrastructure also requires greater oversight. SpaceX must ensure that loose equipment and sensitive instruments are either relocated or secured before launch to prevent damage from extreme vibrations and debris. Beyond direct upgrades, SpaceX must also sustain its current achievements and prepare for upcoming missions. First, the Super Heavy catching effort needs to be further refined and eventually turned into a standard repeatable process before expanding it to the ship itself. Additionally, the successful engine relight in space, first demonstrated in Flight 6, must be validated multiple times to ensure reliability for future missions. Next, preparations for payload deployment and re-entry with heat shield and flap upgrades must continue. These are pivotal milestones in Starship's actual operational roadmap, but SpaceX can only reach them once the fundamental ship issues are resolved. All these upgrades, along with other improvements SpaceX has hinted at, are expected to be incorporated into the next flight. Looking ahead, SpaceX will likely attempt another Super Heavy catch and perform an ocean landing for the ship. Musk has already hinted at a launch timeline of 4 to 6 weeks, meaning that all these enhancements must be implemented in a matter of weeks. Currently, B-16 and S-35 are entering the testing phase. Modifications and upgrades will likely continue throughout testing, both before and after each phase, leading up to the final launch configuration. Testing procedures themselves may also be revised to better simulate real flight conditions, allowing engineers to gather more accurate data for future missions. After 2 consecutive failures on Starship flights, these comprehensive upgrades are critical for SpaceX's next step toward success. The next few weeks will be incredibly demanding for SpaceX's engineers and technicians, who will be working tirelessly to implement these improvements. If you support their efforts, comment "Pursuit of Success" to show your encouragement. And of course, don't forget to like the video and subscribe to our channel to stay updated on SpaceX's groundbreaking progress. Meanwhile, innovation in space isn't limited to launch systems. Let's dive into the exciting return of Varda Space's capsule from its first commercial mission. On February 28th, Varda successfully landed its Winnebago 2, or W2 capsule at the Kuniba test range in South Australia. This marks a significant step forward in space manufacturing and hypersonic technology. The capsule had been in orbit for 6 weeks after launching aboard SpaceX's Falcon 9 on January 14th as part of a ride-share mission carrying 130 other payloads. This mission is particularly noteworthy for its contributions to on-orbit manufacturing and re-entry technology testing. Inside W2, Varda carried an Air Force Research Laboratory spectrometer and a pharmaceutical reactor, both designed to push the boundaries of space-based research and development. The AFRL spectrometer plays a crucial role in hypersonic system testing as it collects optical sensor data during re-entry. This data helps refine technologies for future hypersonic vehicles and spacecraft. Meanwhile, the pharmaceutical reactor builds on Varda's past success. Last year, the company returned antiviral drug crystals that had formed in microgravity, demonstrating the potential for advanced drug production in space. Varda's thermal protection system ensured the safe re-entry of W2 just as it did in the company's first capsule landing in 2024. CEO Will Brewy expressed excitement about the mission's success, stating, "We are ecstatic to have W2 back on our home planet safely and are proud to support significant re-entry research for our government partners as we continue to build a thriving foundation for economic expansion to low Earth orbit." Australian Space Agency head Enrico Palermo also emphasized the importance of this achievement, saying, "This return highlights the opportunity for Australia to become a responsible launch and return hub for the global space community, capitalizing off the geographic advantages of our expansive continent." This mission is a major milestone not only for Varda, but for the future of commercial space re-entry and manufacturing. While these technologies are still in their early stages, the potential is enormous. With continued testing and refinement, space-based production and hypersonic research could revolutionize industries on Earth. Varda's progress is proving that low Earth orbit can be a new frontier for economic expansion. As re-entry capabilities improve, the possibilities for space manufacturing, pharmaceutical advancements, and hypersonic technology will only grow. Exciting times are ahead. Will Varda set the standard for future space re-entry missions? Let me know in the comment section down below. After much anticipation, Flight 8 finally took place, delivering results that were both expected and surprising. The spotlight quickly turned to the issues with S-34, drawing significant attention. At the same time, the FAA made official announcements regarding the flight, raising questions about its impact on SpaceX's future plans for Starship. So how has the FAA responded, and what does this mean for the road ahead? After a month and a half of anticipation, Flight 8 finally took to the skies, carrying immense expectations from the aerospace industry. Once again, SpaceX delivered an impressive feat with Super Heavy, successfully recovering the third Starship booster using the Mechazilla arms catching method. This achievement further solidified the foundation for full reusability. However, the issues with the ship remained unresolved, closely mirroring those of Flight 7. Just minutes into the flight, one vacuum engine failed, followed by 3 sea-level engines, causing an imbalance in thrust and leading to a loss of control. Footage from the engine compartment showed small fires on 2 Raptor vacuums, with the sea-level engines displayed unusual airflow, indicating a potential leak. As a result, Starship once again met a fiery end in a moment reminiscent of Flight 7. This time, the explosion appeared to occur closer to shore, as it was visible from Cape Canaveral, the Bahamas, and the Turks and Caicos Islands. Given the flight path, it is likely that debris drifted into these areas as well. It's also worth noting that although the booster landed successfully, some issues were observed in its engines. While these did not lead to immediate failure, there is no guarantee they won't cause more significant problems in future flights. Following the flight, the FAA quickly responded with an official statement. The FAA is requiring SpaceX to perform a mishap investigation into the loss of the Starship vehicle during launch operations on the 6th of March. During the event, the FAA activated a debris response area and briefly slowed aircraft outside the area where space vehicle debris was falling or stopped aircraft at their departure location. This means SpaceX must now conduct another investigation similar to previous ones to determine the root cause of the failure. In an update on X, SpaceX confirmed, "During Starship's ascent burn, the vehicle experienced a rapid unscheduled disassembly and contact was lost. Our team immediately began coordination with safety officials to implement pre-planned contingency responses. We will review the data from today's flight test to better understand the root cause. Additionally, SpaceX stated, we will conduct a thorough investigation in coordination with the FAA and implement corrective actions to make improvements on future Starship flight tests. Beyond determining the cause of the failure, SpaceX will need to collaborate with the FAA and other relevant agencies to assess the impact of falling debris. This includes working with local authorities in affected areas to evaluate potential damage and ensure public safety. Once these assessments are complete, corrective actions must be taken. For the vehicle itself, SpaceX must implement design upgrades to prevent similar failures in future flights. For the affected regions, the company must swiftly recover debris, address any damages, and take the necessary steps to mitigate risks. Only once these measures are completed will the FAA grant approval for the next flight. Looking at the situation from two perspectives, there are both concerns and reasons for optimism. On the downside, the problems from Flight 7 resurfaced in Flight 8, suggesting that SpaceX's upgrades were not entirely effective. The recurrence of these failures may indicate deeper design flaws, which could take longer to address. Additionally, the proximity of the explosion to populated areas may result in a more complex investigation, potentially delaying future launches. Furthermore, SpaceX now faces two mishap investigations simultaneously. The need to resolve both could slow down the overall Starship development timeline. On the upside, the investigation may proceed quickly. So far, no damage from falling debris has been reported. The FAA also indicated in its statement that this information is preliminary and subject to change, and confirmed that normal operations have resumed. Additionally, because the issue is similar to Flight 7, the investigation may be expedited. SpaceX has already implemented several upgrades and can now refine them further. Another positive aspect is that the Flight 9 mission remains unchanged. Since SpaceX still plans to land the ship in the ocean rather than attempting a launch, no modifications to the existing launch license are needed. This allows the company to focus on addressing technical issues rather than regulatory hurdles. Importantly, the FAA has streamlined its approval processes in recent months, which could further speed up the review and approval timeline. If all goes well, the investigation, issue resolution, and regulatory approvals could be completed within a month, allowing Flight 9 to launch as early as April. However, regulatory approval is only one piece of the puzzle. SpaceX must also ensure the readiness of both the vehicle and the launch infrastructure. Fortunately, Flight 9's booster and ship are already completed and undergoing testing, and the launch system has been refurbished quickly after previous flights. This suggests that pending FAA approval, SpaceX could proceed with the next launch without significant delays. Looking beyond Flight 9, the next major milestone will be Flight 10, which is expected to include an attempt to catch the ship with the Mechazilla arms. While it is disappointing that this test is being pushed back, the additional time allows SpaceX to further refine Tower B in preparation for the catch. A successful catch on the first attempt would be a groundbreaking achievement, and the extra preparation time increases the likelihood of success. Despite the setbacks, SpaceX remains optimistic. In two updates on X, the company emphasized, success comes from what we learn, and today's flight will offer additional lessons to improve Starship's reliability. John Edwards, SpaceX's vice president of Falcon launch vehicles, added, never give up. After Falcon 1 Flight 3, we learned the hard way that the night is darkest just before the dawn. Keep your head up, keep pushing, we're gonna get there. This highlights SpaceX's unwavering commitment to its philosophy of continuous learning and iterative improvement. Each failure provides valuable insights that bring Starship closer to full operational capability. Of course, challenges remain on the path to full reusability, but now is the time to support SpaceX's efforts. In times like these, the team benefits from encouragement from aerospace enthusiasts like us. So if you believe in their mission, respond with "keep on going" in the comment section to show your support. And while SpaceX has faced setbacks, it also has made remarkable progress. So far this year, the company has conducted 2 Starship test flights and successfully landed Super Heavy twice in a row. Speaking of milestones, our team is also working toward one, reaching 200K subscribers. Achieving this goal requires us to work harder and provide even better content, but your support is crucial in making it happen. So if you haven't already, please subscribe to our channel to stay updated on the latest SpaceX developments. Together, we'll continue following this exciting journey toward the future of space exploration. Thank you so much for your support. Meanwhile, on NASA's end, the Artemis program has been at the center of intense debate, particularly as the United States and China compete for dominance in lunar exploration. Critics argue that Artemis faces numerous challenges, and this was a key focus of a recent hearing held by the House Committee on Science, Space and Technology's Space and Aeronautics Subcommittee on February 26th. The hearing, titled Step by Step, the Artemis Program and NASA's Path to Human Exploration of the Moon, Mars, and Beyond, featured space policy experts Dr. Scott Pace, director of the Space Policy Institute at George Washington University, and Dan Dumbacher, adjunct professor at Purdue University. During the hearing, both experts raised concerns about the pace and execution of Artemis. Dumbacher expressed alarm over the growing competition from China, stating,
"Our global competitors, primarily China and its allies, are outplanning and outpacing us in their drive to become dominant in space. This is a critical national security and economic concern."
His statement underscores the urgency for the U.S. to maintain its leadership in lunar exploration, particularly as China aggressively advances its own lunar ambitions. Scott Pace, meanwhile, called for a reassessment of NASA's approach, suggesting that the agency should consider alternatives for getting astronauts to the moon and back. He argued,
"Ideally, NASA should be able to buy heavy lift services to send payloads to the moon. A revised Artemis campaign plan should be a high priority for the new administrator."
This statement hints at a potential shift in strategy, possibly moving away from NASA's traditional reliance on the Space Launch System and considering more cost-effective, commercially available solutions. Pace also emphasized that simply reaching the moon first is not enough. Sustainability must be a priority. He explained,
I would say the immediate campaign plan, if you will, for the next several missions is going to be important to get there ahead of the Chinese, and then we need to be able to think, and how are we going to stay there in a way that's sustainable and affordable.
His remarks highlight a growing consensus that Artemis must transition from a series of one-off missions to a long-term, repeatable presence on the lunar surface. Both Pace and Dumbacher also discussed the role of SLS and Starship in Artemis. Dumbacher expressed skepticism about Starship's readiness, arguing that the number of successful Starship launches need to demonstrate its reliability, making landing humans on the moon by 2030 remote at best. This suggests that NASA may need to rethink its reliance on Starship HLS or introduce contingency plans to avoid delays. The hearing also highlighted NASA's bureaucratic inefficiencies, with discussions on cutting waste, streamlining processes, and fostering a risk-tolerant culture to accelerate Artemis. As 2025 progresses, NASA must refine its approach, maintaining Starship HLS while reducing delays and costs. Should Artemis undergo major changes or stay the course? The way that SpaceX is already gearing up for the next as soon as the moment one flight ends, we can obviously say that they're going non-stop with this one. With the estimated launch time set, Starbase is buzzing with activity as teams work to resolve Flight 8's issues and prepare for the next big launch. So how is SpaceX tackling these challenges and pushing forward? B-15's journey from the orbital launch mount back to the production site's megabay officially marks the end of Flight 8, an eventful mission filled with both record-breaking achievements and technical challenges. Now, all eyes are on Flight 9, the mission that SpaceX hopes will complete a fully successful flight from launch to landing. On March 7th, Musk provided an estimate suggesting Flight 9 could take place in the next 4 to 6 weeks. But what will SpaceX be working on during this critical period of preparation? With B-15's post-flight analysis underway, attention has shifted toward upgrades and preparations. One of the most significant updates involves Ship 35, which has been rolled out for testing, following B-16. A key modification spotted on S-35 is the addition of an actual landing pin in place of the previous landing pin hole, similar to what was seen on S-34 and S-36. This suggests that SpaceX is gearing up to test re-entry capabilities and possibly even attempt a ship catch in the near future. Future preparations were signaled by the movement of the lifting jig system, a crucial tool in handling Starship prototypes. Additionally, on March 9th, a new test stand, referred to as the puck-shucking cryo stand, was transported to Megabay 2. This system, relatively new to SpaceX's testing process, is expected to serve as a cryogenic test stand for S-35. It's likely that this stand has been upgraded to optimize testing efficiency, reflecting SpaceX's ongoing improvements in its vehicle development process. Meanwhile, at the launch site, efforts to repair and upgrade infrastructure are in full swing. On the evening of March 7th and into the morning of March 8th, SpaceX lifted 2 vaporizers from the tank farm, followed by a third a few hours later. Given that the removal system remained in place, it's possible that more vaporizers will be removed in the coming days. These components will likely undergo repairs and improvements before being reinstalled. The need for these repairs became apparent after Flight 8 when images revealed that certain launch pad systems had sustained damage. One vaporizer was found tilted, leaning against another, while other components were scattered around Starbase. Nearby cameras also appeared slightly damaged. The intense vibrations produced by Starship's liftoff were likely responsible for these issues, emphasizing the sheer power of the vehicle. Addressing these problems is crucial for ensuring the reliability of Flight 9's ground support systems. Beyond these immediate repairs, SpaceX will likely focus on upgrading several key systems ahead of the next launch. The orbital launch mount, the launch tower, and the Chopsticks catching mechanism will all require thorough inspections. The OLM's clamp systems, which endured their strongest liftoff yet, will likely need reinforcement. Additionally, the tubing inside the booster quick disconnect system must be checked for any potential issues. Below the OLM, the water-cooled steel plate system will also require careful observation. Despite showing strong performance so far, discoloration observed last year suggests that its longevity could be a concern. Although SpaceX doesn't intend to use this design permanently, it remains an integral part of the launch pad's structure. The Chopsticks system, which played a crucial role in B-15's landing, will also undergo close inspection. This includes monitoring the landing rail and actuator, which are directly involved in the catching process. Before Flight 8, the skate system encountered some issues, and given that the catching mechanism was used again recently, now is the perfect time for SpaceX to evaluate its reliability and make any necessary refinements. As for the launch tower, one of the most critical components is the communication antenna system, which plays a direct role in ensuring successful vehicle capture. There are indications that SpaceX has also integrated a distance measuring function into the system to improve accuracy. Given the importance of this technology, it'll likely be a focal point in the lead-up to Flight 9. With so many upgrades and repairs in motion, SpaceX is wasting no time in pushing Starship toward greater reliability and success. The next few weeks will be packed with testing, improvements, and final preparations as the company works toward what could be its most successful Starship mission yet. At the tank farm, beyond the vaporizer upgrades already mentioned, additional improvements are necessary to enhance resilience against the intense effects of each launch. One significant change being considered is a complete conversion to a horizontal system, which would mitigate damage from the extreme vibrations and forces experienced during liftoff. Meanwhile, long-term preparations at Starbase continue at full speed. On March 7th, SpaceX raised its massive crane system, likely signaling the final stages of Pad B's construction. This new launch pad may include a flame bucket or an orbital launch mount system, similar to the one at Pad A. Additionally, modifications to the Chopsticks catching mechanism are underway, including an upgraded lateral stop block. With the recent challenges faced during Flight 8, a full ship catch attempt may be delayed, allowing more time for thorough testing and construction at Pad B. However, for Flight 9 to proceed on schedule, the pad must ideally be completed within the next 4 to 6 weeks. On the vehicle side, B-16 has successfully completed cryogenic testing at Massey and will soon return to the production site for engine installation. Once the engines are integrated, it'll wait for the launch pad refurbishments to finish before conducting static fire testing. Following this critical step, B-16 will return to the production site for further inspections and final installation in preparation for integration testing and flight. During this process, B-16 will undergo extensive checks to ensure a successful mission. One of the primary concerns will be the engine system, particularly after separation. This issue was also observed on Flight 7, and while SpaceX has already made significant upgrades based on Elon Musk's post-flight analysis, further refinements will be necessary to guarantee sustained performance. The fuel pump system will also require reinforcements to prevent pressure instabilities, and the hot staging mechanism will undergo rigorous testing before installation to avoid potential failures. Ship 35 is also advancing through its pre-flight preparations. After its recent rollout, it is now awaiting cryogenic testing, followed by a series of steps similar to B-16's process. In particular, S-35 will need to be equipped with its payload system, requiring additional modifications. Like B-16, its engine system will be a focal point of testing to address issues seen in previous Starship flights. Both Flight 7 and Flight 8 demonstrated that ships tend to encounter severe problems post-separation, cutting their journeys short. Beyond ascent performance, the engines play a crucial role in future space missions as well as in deceleration and controlled navigation for landing. Furthermore, S-35's flap and heat shield systems will undergo extensive validation. These components have received upgrades compared to earlier versions, but they have yet to prove their effectiveness in real-world conditions. Given the extreme heat and aerodynamic forces Starship experiences during re-entry, ensuring these systems function as intended is critical to long-term mission success. In addition to hardware modifications, SpaceX must swiftly conclude its investigation into Flight 8's anomalies and implement corrective actions in coordination with the FAA. Simultaneously, efforts must be made to address any debris recovery or environmental impact concerns in affected areas. SpaceX has already committed to funding cleanup efforts in locations such as the Bahamas, reinforcing its responsibility in mitigating any unintended consequences from the flight. As for the flight profile, no major changes are expected. Super Heavy is still planned to attempt a landing on Mechazilla's arms, while the ship will splash down in the ocean. This means that final preparations for the landing zones will need to be completed in the coming weeks to ensure a smooth recovery operation. Following 2 flights that fell short of full mission success, SpaceX's determination to achieve a breakthrough with Flight 9 is stronger than ever. Every step taken now, every upgrade, every test, and every modification is aimed at reaching that critical milestone. If you're as excited as we are for the next launch, don't forget to like the video and subscribe to our channel to stay updated on SpaceX's incredible journey toward the future of spaceflight. Now, for our final bit of today's news, let's talk about the recent return of the X-37B spaceplane, a remarkable mission that once again pushed the boundaries of space operations. After an impressive 434 days in orbit, the X-37B Orbital Test Vehicle 7, or OTV-7, of the U.S. Space Force successfully returned to Earth. The autonomous spaceplane made its landing at 2:22 a.m. Eastern at Vandenberg Space Force Base in California. That's 11:22 p.m. Pacific, marking yet another milestone for this secretive and highly advanced program. Before its return, the USSF provided a rare glimpse into the mission, releasing an image captured from a camera aboard the X-37B. The breathtaking shot showed Earth alongside the spacecraft's payload bay and solar panel system. Along with the image, the USSF confirmed that OTV-7 had been conducting experiments in a highly elliptical orbit throughout the past year, including an aerobraking test designed to change its orbit while using minimal fuel. Aerobraking is a unique capability of the X-37B, allowing it to use atmospheric drag to adjust its trajectory, a maneuver typically associated with the interplanetary probes rather than Earth-orbiting vehicles. In a statement, Chief of Space Operations Chance Saltzman highlighted the significance of this achievement, stating, "Mission 7 broke new ground by showcasing the X-37B's ability to flexibly accomplish its test and experimentation objectives across orbital regimes. The successful execution of the aerobraking maneuver underscores the U.S. Space Force's commitment to pushing the bounds of space novel operations in a safe and responsible manner." Blaine Stewart, X-37B program director, further emphasized the mission's impact. Mission 7's operation in a new orbital regime, its novel aerobraking maneuver, and its testing of space domain awareness experiments have written an exciting new chapter in the X-37B program. Considered together, they mark a significant milestone in the ongoing development of the U.S. Space Force's dynamic mission capability. Beyond its groundbreaking maneuverability, this mission made history as the first X-37B launch aboard a SpaceX Falcon Heavy, reaching a highly elliptical orbit for the first time. This is yet another incredible achievement for the X-37B program, proving its growing versatility and value to the USSF. With each mission, it continues to demonstrate new capabilities, and with SpaceX providing launch support, the future looks bright for even more ambitious flights ahead. This has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly in the latest details of SpaceX's progress. Thank you so much for tuning in, and remember, curiosity, imagination, and inspiration